Okay, welcome back. We are starting with 3.7, which is some triangle inequalities. So a couple different things to talk about and some examples for you as well in this video. So first up, the first thing to understand is that in a triangle, the largest side is opposite the largest angle. So if I were to highlight the largest angle, which would be this one down here, right, I would know also that this is the longest side, okay? The smallest side, oops, let me undo that and do that in pen. The smallest side is going to be opposite the smallest angle, and then, the middle one is going to be the same too. Okay, so when we say opposite, right, we mean that it points to, this angle points to this side, this angle points to this side, this angle points to this side, okay? But so again, the largest angle, so this one that I've highlighted in blue is obtuse, and so that is going to be opposite the largest side. Okay, so if we know either the sides or the angles, we can order the side length. Okay, so here's an example of what I mean. Okay, so it says list the angles in order from least to greatest. However, these are side lengths that were given, but because of that property we just talked about, we can use the side length information to find the angles. So we're going from least to greatest. So the way that I do this is I find the smallest side, which in this case would be this 14, and its opposite angle is angle L, so that's going to be the smallest side, smallest angle. The next biggest side would be this 18, which is opposite angle M, so that would be next. And then lastly, we would have 21, which is opposite angle R. So from least to greatest, your angles would be angle L, angle M, and then angle R. And again, we know that because of the side measures that are given to us. I can do the opposite thing as well. So I want to list the sides in order from least to greatest. However, I'm given 3 different angle measures. Same idea as what we just did on the last one, but now I'm using the angle measures to determine things about the sides. So again, I'm going least to greatest. So the smallest angle is angle D. Its opposite side would be ST. Okay, next smallest angle would be 58. Its opposite side would be DT. And then biggest angle would be 79. Its opposite side would be DS. Okay, so again, even though I'm given the angles, I can figure out things about the sides because of that triangle property that we talked about. The smallest angle is opposite the shortest side. The largest angle is always opposite the longest side. Okay, now this one we're going to do the same thing. List the sides. List the sides from longest to shortest. Now, I don't know what these angles are, right? But I can do some math here to figure that out. I know all the angles in a triangle have to add up to 180. So first I'm going to figure out what x is to figure out what each angle is. So let's add our like terms. I have 5 and 6 and 1. So that is 12x. And then I have 2 minus 10, which is negative 8, plus 20, so that would be plus 12. Okay, so subtract 12, I get 12x equals 168. Divide by 12. And again, if you were doing this on your own, this is not something that you have to do in your head. You can use your calculator. So x equals 14. Okay, so then what I'm going to do is I'm going to go and plug that into each of these expressions for my angles to figure out what these values are. So if I'm looking at angle A, I'm going to do 5 times 14 plus 2. That's 72 degrees. Okay, angle B, 6 times 14 minus 10. That's 74. And then angle C, I'm just doing 14 plus 20. That's 34. Okay, so now I have the angle measures, so I can use those to find the sides. Okay, now I'm going longest to shortest. So if I want the longest side, I need to find the largest angle, which is the 74. Its opposite side would be AC. Okay, next, smallest would be the 72, angle A, so its opposite side would be BC. And then last, smallest would be 34, so its opposite side is AB. Okay, so again, first step, solve for x, because we know all the angles in a triangle add up to 180. Once I find x, I can plug it in to find the angle measures, and then I can use the angle measures to find the order of the sides. Okay, next up is the side length inequality theorem, which says that the sum of any two measures of any two sides has to be greater than the measure of the third side. So if I have A, B, and C, right? A plus B has to be greater than C, but I can do that with any two sides. So B plus C has to be greater than A, right? And A plus C has to be greater than B. So all three of these have to be true in order for this to work. Okay, so let's look at an example. Can the three numbers be measures of sides of a triangle? So I'm going to just take and do the first two. So is 6 plus 7 greater than 9? Well, 6 plus 7 is 13, so that one works. Okay, next one. Is 7 plus 9 greater than 6? That's 16 greater than 6? Yes, that works. Okay, is 6 plus 9 greater than 7? That's 15. So that works. However, right, again, it has to be all three. So this would be a yes, would be my final answer. I've shown my work that all of these work, right? If you were doing this and you had any of these three that didn't work, it's an automatic no, because in order for it to be a yes, all three have to work. Okay, all three have to be the same. Okay, another thing you might see is something like this that says state a possible third side of a triangle. Okay, so again, we have to think about this 3 plus 6 has to be greater than the third number, but then 6 plus whatever this side is has to be greater than 3, right? It all has to work, okay? So the easiest way to figure this out is you're going to take 3 plus 6, which is 9. That gives you the largest possible side. And then you're going to take 6 minus 3, and that gives you the smallest possible side. Okay, so the possible third side could be anywhere from 3. Whoops. It shouldn't be less than or great. Whoops. Okay, so it has to be greater than 3 and less than 9. So that's how we write that. Okay, so x is between 3 and 9. Any of those would work, right? Let's say if I pick 4. Well, 3 plus 4 is 7. That's greater than 6. 6 plus 4 is 10. That's greater than 3. And 3 plus 4 is 7, which is greater than 6. Okay, 6 plus 3, 9, greater than 4. So anything in this range would be a third possible side for that triangle. Last thing we have to talk about is the right triangle inequality theorem. Okay, so we can use the Pythagorean theorem to help us with this. It is going to help us classify if we have a right triangle, an acute triangle, or a obtuse triangle. Okay, so the first one, that's easy. A squared plus b squared equals c squared, right? That's if we have a right triangle. That is the Pythagorean theorem. Okay, if I'm looking at this first one, a squared plus b squared is greater than c squared, that tells us we have an acute triangle. And this bottom one, if c squared is biggest, a squared plus b squared is less than c squared, Then we have an obtuse triangle. So this just gives us a way to classify these triangles without actually having to draw them out and see how they would fit. Okay, so the measures of three sides of a triangle are given. Determine whether each triangle is a right triangle. So here, all we're doing is determining if it's a right triangle. So all I have to do is say, does 20 squared plus 21 squared equals 28 squared? Remember, the biggest value is always C. The other two, it doesn't really matter which one we take as A, which one we take as B. The biggest number is the one that matters, and that is always C. So 20 squared is 400. 21 squared is 441. 28 squared is 784. Okay, so this is 841, and that does not equal 784. So this is not a right triangle. So that would be my answer. This up here is the work that proves that answer. Okay, now this is where we're going to have to use those inequalities to figure out which triangle, to classify. So we're saying, are they acute, right, or obtuse? So I'm just going to compare, again, the largest side is always C. So I'm going to look at 6 squared and 11 squared, and I'm going to compare that to 14 squared. Okay, so if I take 6 squared, which is 36, plus 11 squared, I get 157. And 14 squared is 196. Okay, so since C squared is biggest, this would be obtuse. Right? A squared plus B squared is less than C squared. So that is an obtuse triangle. Can do the same thing down here. Again, this 6 has to be my C because that's the biggest side. So 4 squared plus 5 squared. I'm going to compare that to 6 squared. So 16 plus 25 is 41. 6 squared is 36. So this time A squared plus B squared is greater. So that is acute. Okay. And that is it for this. I know that was kind of a lot. We will spend some time in class going over more examples of this. But I would save this video and then return back to it if you need to watch it again to get a little extra help.